Okay guys, in this video we're going to continue our work with indices and have a look at some more rules, namely what happens if we have an indice or a power that's a fraction. So as you can see by this example here, I've got x squared to the power of a half times x squared to the power of a half. Now going back to our very first video when we're timesing something like this and we add the powers. So obviously a half plus a half would obviously equal 1. So this example here, it leads us on to what it means to be to the power of a half. Well, something times itself, so x to the power of a half times x to the power of a half equals x to the power of 1. Okay, so this times this gets me x to the power of 1. What does that mean then? So x to the power of a half must just mean the square root of x. If I square root this, what do I get? Well, I get x to the power of a half, must be. So this rule here is why we can say that x to the power of 1/2 is the same as saying the square root. If I then carry on the pattern on, if I was to do x to the power of a third, that would be the cube root, x to the power of 1/4 would be the fourth root, and so on and so forth. Okay, so whatever the denominator is, if it's a 2, it's a square root, if it's a 3, it's the cube root, if it was to a fourth, it would be the fourth root. Okay, so if we have a look at some examples, if I have 49 to the power of a half, like I just said, if it's to the power of a half, it just means the square root. So it's the square root of 49. And you should know your square numbers. Obviously the square root of 79 is 7 because 7 times 7 is 49. This one here, 8 to the power of 1/3. Well, that's the cube root of 8. So that's going to be 2 because 2 times 2 is 4 times 2 is 8. And let's have a look at this one again. So again, it's the power of a third. So this time it's going to, well, it's the same. It's the cube root of 64. You might not know your cube numbers, but hopefully you should. And that's going to give you 4 because 4 times 4 is 16. Times by 4 again, that's going to give you the 64. So the cube root of 64 is 4. And finally, here, you might not be able to see it on the camera, but that's to the power of 1/5. So it's going to be the fifth root of 32. And there's only one number that's going to be, and that is 2. Because 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 again is your 32. Okay, so that's the very basic rule. If it's a fraction, the denominator tells you what root to do. So let's step it up. What if the numerator isn't 1, like in this case here, where it's x to the power of 3/2. Now what you can do is use that very first rule we did in our first video and go, okay, well 3/2 is exactly the same as saying 1/2 times by 3. So in other words, I've got x to the power of 1/2 times 3. Now if we separate that up, what does x to the power of a half mean? Well, we just realised that was the square root. So I need to square root x, and then I also need to cube it. That's what that times 3 is. There's 2 steps involved here. The x to the power of a half means I square root it, and then obviously the 3 means I need to then cube it. So let's go through some examples and see what we come up with. So here's my first one. So I've got 9 to the power of 3/2. So the 2, the denominator being a 2, means I need to square root the 9, and the 3 on the top, the numerator, tells me I need to cube it. Well, square root of 9 is 3, and I still need to cube it, so 3 cubed is 27. Let's carry on. 32 to the power of 3/5. So the 5, the denominator is a 5, so that means I need to fifth root it. So fifth root of 32, and the 3 as the numerator tells me I then need to cube it. So let's work that out. Well, the fifth root of 32, we've already done that. That was 2. Leave in brackets if you want, don't have to. And 2 cubed, well 2 times 2 is 4, times 2 again, leaves us with 8. 64 to the power of 2/3. Well, 3 is the denominator, so that's my root. So I'm going to cube root the 64 because it's a 3. And then what's the numerator? It's a 2. So I'm going to square it. What is the cube root of 64? Well, again, we've already done it over here. The cube root of 64 was 4. So 4, don't forget to carry on with the squared. And then 4 squared is 16. And last one for this example, if I have 81 to the power of 3/4, the 4 is the denominator, so it's the 4th root of 81. And again, the numerator there is 3, so I've still got to cube it. 4th root of 81, that's going to be 3. Because 3 times 3 times 3 times 3 gives me 81, so that's why the 4th root of 81 is 3. Don't forget, I've still got to cube it. Again, you put it in brackets like I did there. It's entirely up to you. But 3 cubed, you should know that one, is 27. Okay, so that's what happens if your indice or your power is a fraction. Let's have a look at what happens if it's the power of a negative. That one's nice and easy. Consider it to be a fraction, and you just flip it. So for example, if it was x to the power of -1, that just flips to be 1 over x. And if it was x to the power of -2, for example, again it flips to be 1 over x squared. That probably might not make too much sense, but let's have a look at some examples, and hopefully that will make sense. First thing I would always do is look at the number. In this case, it's 5. If it's not a fraction, think of it as a fraction. And you might know this from multiplying fractions and dividing and all that. That 5 as a fraction is just 5 over 1. Okay, so that's the first thing that I would do. Consider it as a fraction, and then we just use this rule. Flip it. It's the power of -1, so it's the power of minus, so it means I flip it. So all I'm going to do is flip that fraction, so the answer would be 1 over 5. It's as simple as that. Again, this one here, 3 to the power of -2. Consider it as a fraction, so 3 over 1. Because it's the power of a minus, I flip it. In which case I'm going to have 1 over 3. Now what you might notice is that that's -2 and this is a -1. So what does that mean? Well, the minus means we flip it, done that, but I've still got that squared. So technically what we need to do is square everything. Well, 1 squared is 1 and 3 squared is 9. The reason why I didn't do it here, you might have already guessed it, is if I was to do that, it would be to the power of 1. Well, anything to the power of the 1 is just the same, so it stays exactly the same. But if you wanted to, you can do it like that. Let's have a go at this one then. So 5 to the power of -3. Again, consider it as a fraction. So 5 over 1. It's the power of a minus, so I flip it. So it's going to be 1 over 5. I've still got to cube it, so there's my cubed. 1 cubed is 1. 5 cubed, 125. Okay, so the minus just means you flip it, and then you do everything else that you need to do. This one here looks a bit more complicated. It isn't. It's just already a fraction, so that's handy. It's the power of a -3, so I'm just going to flip it, do the minus first. So that's going to be 2 over 1. And then obviously then it's cubed. So, well, let's just simplify this first. We're going to have that 2 divided by 1. Well, that's easy. That's just 2. But obviously it's still cubed. So 2 cubed, 2 times 2 is 4, times 2 is 8. And final one for this page, again, it's -3, sorry, to the power of -3. So let's deal with the minus first. The minus just means we flip it, so that's 5 over 2. But I've still got that cube there. So we do 5 cubed, 125, and then 2 cubed is 8. Okay, so that would be the answer to that one. So do it step by step. If it's negative, flip it, and then you can do your cubes. So, you might be wondering, what happens if it's a fraction to the power of a fraction? Good question. This is what we do. So hopefully this then, after we've done this, will be everything you need to know for indices. So let's use this example here. I've got 9 over 4, and that's the power of 3 over 2. So let's think about this power of 3 over 2, just like we did before. The denominator is 2, which means I need to square root it. So I need to square root the 9, and I need to square root that 4. So let's just write that down. The square root of 9 over the square root of 4. And the numerator is 3, so I still need to cube it. Let's do a little bit of simplifying then. The square root of 9 is 3, and the square root of 4 is 2. Still got to cube it. Well, 3 cubed is 27, and 2 cubed is 8. So that would be your answer there. So, next one, getting really tasty now. So we've got a fraction to the power of minus another fraction. Again, looks horrible. People always then go, oh, can't do it. Just take it step by step. First thing I'm going to deal with is that minus. The minus, just like I said before on the other side, just means you flip it. So instead of being 9 over 4, I'm going to call it 4 over 9. And I've dealt with that minus, so it's just going to be to the power of 3 over 2. Okay, so I've now dealt with that minus just by flipping it. Good times. Again, we've got this 3 over 2, so the 2 is the denominator. That means I'm going to square root it. So square root 4, square root 9. And the numerator, the top number there is 3, so I've still got to cube it. Let's do a bit of simplifying. Square root of 4 is 2. Square root of 9 is 3. I should still have that in brackets because I still got to cube it all. And 2 cubed is 8. And 3 cubed is 27. And last but not least, again, another fraction here. And I've got to the power of minus 2/3. So again, take it step by step. I'm going to deal with that negative initially, which means I'm just going to flip it. So instead of being 27 over 8, it's going to be 8 over 27. That's it. That minus is now dealt with. So I'm now left with 2/3. The denominator there is a 3. It means I'm going to cube root it. So the cube root of 8 and the cube root of 27. And the top number there, the numerator, is a 2, so then I'm going to square it. Cube root of 8 is 2. Cube root of 27 is 3. And I've still got to square it. 2 squared is 4. 3 squared is 9. Okay, so take it step by step. If it's a minus, you flip it. If it's got a denominator, that's your root. If it's got a numerator, that's going to be what you need to do, like square it or cube it or so on and so forth. Hopefully that explains in all 3 parts, part 1, 2 and 3 on indices, everything that you need to know. Again, if you've got any questions or queries, do ask your teacher. Cheers, guys.